My name is Maria Kravchenko. I come from DTU, the Danish Technical University that is located in Lyngby next to Copenhagen. I'm very happy to present the tool I'm developing because we have heard the word sustainability many times today. And the tool I present is the sustainability screening that allows for the screening of circular economy strategies on their potential impact towards sustainability. So what we have heard today is that circular economy is much more than just recycling. It's also about the way we approach the products. It is the way we rethink the products are being produced, used, and then reused. So it's going beyond the usual life cycle of a product. It's also about rethinking how we design systems around our products, how we actually redesign whole business model or business concepts that change the way we operate in our current economy. So the basic idea behind circular economy is obviously giving businesses new opportunities to profit, but also to give some benefit for the environment or to sustainability. That's why many associate circular economy as being something that is more sustainable by default. But is it always like that? That's what we are trying to find out. So here the question in focus: does circular economy always bring the desired sustainability as the end goal? And how do you, as a decision maker, like being in a company, how do you make a decision whether the circular economy that you have in mind that you want to implement is good as it is or has to be improved or enhanced? How do you decide which circular economy strategy potentially is worth pursuing depending on its impact to sustainability? And then how do you later monitor and measure whether or to what extent the idea or the strategy that you have implemented has actually made a positive contribution, not a negative one? So hence the tool called Sustainability Screening Tool of Circular Economy. And it's not the average tool that allows you to calculate your global warming potential or human toxicity. It's the tool that allows you in very early stages of decision making to identify what circular economy strategy is the most applicable in your case, like depending on the product type or business context, and then screen it against sustainability performance using key performance indicators that the tool contains. So the tool allows defining you the specific scope that you want to test, and then the tool gives you more than 300 key performance indicators that could potentially be used to identify your idea, to identify the potential impact of your idea. Together with the tool, there is a guidance that helps you to identify which are actually the strategies that you are thinking of, and then what are the business processes that you might be involving or affecting. So today, come at my workshop to see how do we actually select relevant strategies for that specific case that we presented at the toothbrush. How do we identify what applies to the case? How do we identify what business processes are involved? Because as Fenna mentioned, circular economy is not done in isolation. It's a combination of configurations of several activities. And then how do we select the final set of KPIs and how do we use them? So once you engage with Work Package 1, you get access to the tool, which consists of the database of more than 300 key performance indicators, and then the corresponding guide that will help you to narrow down gradually and then navigate in those 300, because it's quite time consuming to navigate. So the guide will help you to narrow down automatically the set of KPIs that could potentially be useful for your own case. Then just come and join.
Package 3 is about the circular product design. So we talked about the circular strategies that Fiona presented. So for example, let's say we want to have a product service system in place. Do we want to use the same kind of product that we designed for normal use? No, it's not. We want to have a product that is durable. We want to have a product that is designed for product service system. So depending on each of these strategy, the products that we design and develop are completely different. So what we do in the project that we go through this generic product development process that we use as a reference in the project. Of course, each of your companies have their own kind of product development process, depending on the project, depending on a product, depending on the production system. That can be different, of course. But this one we use, and we try to map your product development process based on that. And then we try, what we want to do is to include circularity aspect within each of these stages. So what does that mean? The product development process has lots of function involved, lots of things that has to be done with different. I mean, this is the three main function that has to do a lot of things. So what we do is to go to and pick up the things that is really important in each of these stages, that are like a milestone that you have to fulfill in order to design your product in a circular way. And also during the process, we also go through different tools and methods or principles that exist that help you within the process. For example, there is this is exactly what we do today. I'm trying to develop, in the work package, we're trying to develop guidelines that fit into these different really strategies. So we have a generic product development, we map the product development process of yours, and then we try to put them into the product development process. So today we are not going through all of them. We don't have time. We don't have a product development process in place right now that we talked about. So we just talked about these remanufacturing and recycling within the concept development, because these two parts are really important. The earlier that we start working with the design, circularity design, the better. And we try to use the guidelines for design for recycling for this product that Fena presented, and also remanufacturing. These are the only two examples. Maybe remanufacturing is not that much of for this product, that doesn't make sense that much, but that's what we try to do and think about. Yeah.
We're package 4, and it has a lot of different names: digitalization, IoT, intelligent assets, smart circular product operation. It's basically trying to see what does IT deliver to circular economy. And to be quite short, the work package and our work can be divided into two parts. First part is trying to figure out what type of smart circular economy strategy would you like to pursue. That's the focus for this workshop. And basically the main body of our work is on the constructing data analysis models using sensory data from IoT and artificial intelligence for circular economy. So then once you've chosen a particular smart circular economy, I'll come with some examples, then how do you make that concrete in order to enable the circular economy and concrete product service systems. Many of the examples that Fana mentioned, especially on the reinvent, access-based and performance-based models in particular, those cannot be done without this knowledge here. So IoT is seen as one of the key enablers for circular economy and sort of the glue that makes the new circular business models and product designs possible in the real world. There's a lot of different buzzwords and confusion on IoT, big data, artificial intelligence, machine learning, deep learning. I can go on. Many times I'm confused myself. We made this framework called Smart Circular Economy Framework, which basically organizes all this, and this will also be shared afterwards, and puts the different buzzwords into where they belong and how, and is associated with some example strategies. So we will use a downscale version of this today. One example is looking at maintenance. So at the lowest level of what we call maturity can be a reactive maintenance. You put an IoT sensor on the device and it says, now something's wrong, come and fix me. One step up, using some AI, having a condition-based maintenance, so trying to make some diagnostic analysis of, okay, what is going on, why am I failing? Maybe it's too high heat or something. And then the end goal is prescriptive and predictive maintenance. So you would like to predict and know when the machine might fail, so that you can order in spare parts in advance, reduce downtime, extend the life cycle of the product, and a lot of different positive value drivers for the circular economy. So today we will focus on those 3 levels, which you will get some insight on what does they mean, to basically try to identify some smart strategies for the toothbrush in particular at different levels, and you'll get some insight on basically what does some of these buzzwords mean in reality. Thank you.